All right, this is stats, this is 12.1 notes, and this is part 2, how to run a significance test. So again, we're going to just do the most basic straightforward ones where they give us a computer output to read. And so now we remember how to actually read these, right? So we know that the first column is A and this one's B, and that our standard formula is the predicted Y is A plus BX. So B represents the slope. All right, notice now this is about something else, something to do. Can we use increased daily temperatures to predict increased swimsuit sales? And again, they told us that this is using 46 samples, 46 items. Okay, notice also at the end that they are giving us some of the standard deviation from our prediction on the line, and our R squared is also here as well. So let's take a look at what this one would look like. So on this one, we will have a parameter where we're going to explain that beta is the true slope of, okay, and our null and our alternative hypothesis is always going to start out with that the null is beta equals 0. So no slope means there's no pattern, there's nothing, there's no relationship between stuff, just the dots are all scattered, there's no slope, the best fit line is kind of a horizontal line. The alternative could be any one of those three. It could be equal to or greater than 0, and that really depends on the context. So if they said, could there be a difference in the sales, then it would be not equals. Are the sales reduced? Then it'd be less than. Are the sales increased? Would be greater than. So because they use the word greater than, we would be using greater than 0 on this one. Okay. And it's going to ask us a few other questions here just as we go through. So we would say y hat equals 11.418 plus 0.04139 x. And remember, we talked about if I do this, then I have to identify what y hat is. So we're going to go back and we're going to fix this a little bit so that I don't have to do that. So instead of y hat represents the predicted sales. And then the x, we can say, is the temperature. Okay. Okay, to leave them as x's and y's, you just then have to go over and explain what those are anyway. So it says, what does SE sub B1 stand for? So this is the standard error of the slope. And in our case, it's going to equal 0.06032. So we have now looked at these three numbers off the table. So it's not a shocker that if the 11 is the y-intercept, then the next is the y-intercepts error, standard error, okay? All right, on to the next thing. Let's go find our t values. So this would go under the t in phantoms where we actually calculate a t. So here is our formula for t. It's just slope over standard deviation, or standard. Okay, so when we do this one, we will get t equals 0.04139 over 0.06032, and if I calculate those two, so get out of this one, 0.04139 divided by 0.06032 gives me a t value of 0.686. Wait a minute, didn't I see that somewhere? Look at that. So for a confidence test, for a significance test, they're actually also giving you your t statistic. So there it is. So if we're doing it on y-intercept, we'd use the 4.29. We're doing it on slope, and that is the most common. That's what we're expecting to see if they ask us to do a confidence interval or significance test on slope. It's going to be on slope. It's not going to be on y-intercept. Okay. So are you kind of wondering if maybe this p-value has to do with our p-value at the end as well? Let's go see. Okay. So our next step would be after we found t, what would we do? We'd draw a picture, right? And we'd say this is a t distribution. So we'd say here is where t is 0. We're going to say t is 0.686 right about here, and since it's a greater than, we're coloring in to the right. We would say this is a t distribution, and we'd say degree of freedom is going to be n minus 2, and they told us this time that it was 46, I think, 46. So 46 minus 2 is 44 for degrees of freedom. All right, so next step is we're going to go to our probability statement. So the probability that T is greater, and again, this is matching our HA, greater than 0.686 is starting at 0.686, going to infinity with the degree of freedom equals 44, and I'm back to my calculator. So second vars T CDF starting out at 0.686, going to some really humongous number. Degree of freedom is 44. And we are going to get a p-value of 0.248. So let's go back and take a look. Ooh, not 0.248. But I'm going to go to my calculator and I'm going to multiply that answer by 2. Look at how close that is. If I multiply it by 2, in other words, if I had a negative 0.686 and it was a two-tailed test, this is the probability or the p-value for a two-tailed test. And a two-tailed test would be the ones that uses the not equals in the HA. If they're doing an alternative that is a not equals, then that's exactly the number we'd be using is 0.49. Since it's not, I would just have to divide it by 2 and I'd be really close, or I could go about it the longer way, which is right here, using RT-CDF to do that. All right. Okay, so on to the p-value. We have a p-value of 0.2496. And if we had an alpha level of 0.05, that is definitely bigger. So we would fail to reject HO. Meaning we do not have convincing evidence that whatever the HA is, and in this case it would be that increased daily temps could be used to predict that increased daily temps can be used to predict swimsuit sales. So they're saying that this happens by chance about 25% of the time, and that's way too big of a probability to be enough for us to change our opinion of what the null hypothesis is. So same deal here. We do have, under stat test, we do have a linear regression t-test, that's letter F, but we have the exact same problem here. We have to know what the two lists are in order for us to do that. So we have to have the raw data. So once again, this is going to be meaningless if they give you a computer printout. And that is the most likely way that they're going to do it. So that's the way we're going to practice it. Okay. All right. That's it for this one. And we've got one more left.